Hello, in this video we will talk about theorems about roots of polynomial equation, which is actually lesson 5-5. The objectives of this lesson to solve equations using the rational root theorem and to use the conjugate root theorem. Okay. The first theorem is rational root theorem. This theorem says that if we have a polynomial p of x a n x to the power n plus a naught be a polynomial with integers coefficients, okay? There are a limited number of possible roots of p of x equals to 0. Integer roots must be factors of a naught. So the integer roots of this polynomial must be factors of a naught, and the rational roots must have reduced form of p over x, where p is an integer factor of a naught and q is an integer factor of a naught. Look at this example. 21x squared plus 29x plus 10 equals to 0. So the root of this equation, since the coefficient in each term is integer, we just apply the rational root theorem. So the solutions or the root of the zeros or the solutions of this equation must be the factors of the form p over q, where p is factors of 20 and q factors of 10 and of 21. This is factors of positive 10, and this is factors of 21. So the factors of 10 are plus minus 1, right? And plus minus 2 and plus minus 5 and plus minus 10. So we have 8 factors, right? This is 10, okay? This is 10. And the factor of 21, the factors of 21 are plus minus 1, plus minus 3, plus minus 7, plus minus 21. So this is the possible values of p, and this is the possible values of q. So the solutions of this equation will be one over 1 or negative 1, it's 1, or minus 1 over 1 or negative 1, it's minus 1, or 2 over 1 or negative 1 or negative 2, also 2 over 1 or plus minus 5. So it's plus 5 minus 5 plus 10 minus 10, okay? Then 1 over 3 or negative 1 over 3, okay? 2 over 3 or negative 2 over 3, 5 over 3 and negative 5 over 3, okay? Also 10 over 3, negative 10 over 3, or 5 over 1 or negative 5 over 1, it's negative 5 over 3, 5 over 3 here, negative 5 over 3, 5 over 7, or positive negative 5 over 7, positive negative 10 over 7, or positive negative or 1 over 21, positive negative 1 over 21, or positive negative 2 over 21, or positive negative 5 over 21, or positive negative 10 over 21. So we have all these numbers are possible to be the zeros of this equation. Now just we will try. So the answer here is negative 2 over 3 and negative 7 over negative 5 over 7. Okay, same story here. The only possible rational roots have the form factor of constant term or the factor of leading coefficient term. Note that here we have the constant term is positive 1 and the leading coefficient of the leading coefficient here is 2. Leading mean the term of the highest power. Okay, so the only rational roots here of 2x cubed minus x squared plus 2x plus 5 equals to 0 is 1. Now the second theorem is conjugate root theorem. If p of x is a polynomial with rational coefficients, then irrational roots of p of x equals to 0 that have the form a plus square root of b occur in conjugate pairs. That is, if a plus the square root of b is an irrational root with ab rational, then a minus b is also root for this polynomial. Same story for complex numbers. If p of x is a polynomial with real coefficients, then the complex roots of p of x equals to 0 occur in conjugate pairs. That is, if a plus pi is a complex root with ab real, then a minus pi is also root. This very simple theorem. Just if we have a polynomial, p of x equals to 0. If we have one of the solution of this polynomial of the form a plus square root of b, then the conjugate of this expression will be appear, okay, as root of this polynomial. A minus b, the square root of minus b is also solution for this polynomial. A minus the square root of b is also solution. Same story, if a plus pi complex root for this polynomial, then the conjugate of this solution is also solution for this polynomial. The conjugate of a plus pi is a minus pi. It's just very simple theorem. Using the conjugate root theorem to identify the roots. A quartic polynomial p of x has rational coefficients if the square root of 2 and 1 plus I are roots of p of x equals to 0. What are the two other roots? So by applying the conjugate root theorem, the other roots are negative square root of 2 and 1 minus I. Okay. So, okay, that's enough in this video. Thank you so much.